you've never gone back and looked at the, you've never gone back and looked at the tapes from any of the ones I've done, right? Okay, excellent. And I'm trying to figure out. I need to go. I need to go find where I am in NEDACO. So I just need to grab a. Yeah. 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 No, I mean, I know where to look. I just need to go there. No, I mean, last time, 30 minutes, I'm telling you. Only 20 of it was with people in the room, but still, Jesus Louise. Um, I also uh, make we've got some remote presenters. I wasn't sure I was going to be. Um, Hi everybody. We're just getting ready to get started here, and I think we're ready to get started. And I think everybody has come over from the welcome reception. I am Spencer Dawkins. This is the lovely Alexa Moritz. And we are joined in spirit by Liz Flynn, also of the Secretariat, who was expecting to be here right up until she was not feeling well and is up resting in her room. So please keep her in our thoughts as well. We can do next slide. Okay. This is the first session of this IETF meeting, so will be some newcomers who have not seen the note well at the beginning of every session, and there will be some who haven't seen it in 4 months and haven't thought about it. This is basically covering the obligations of someone who's contributing to the IETF, which is what HOTRFC topics are doing. So please keep an eye on that as you participate, whether you're speaking or whether you're telling people where to find you after the meeting. So in-person participants, please sign in using the Meet Echo, probably the Light client. This does the blue sheets. And please wear masks unless you are actively speaking at the microphone. And if you are using the full thing, please keep your audio and slides off if you're not using the on-site version. And use masks, as I say, unless actively speaking at the microphone. Remote participants, please make sure your audio and slides are off unless you are sharing or presenting during a session, and the use of a headset is strongly recommended. Next slide, please. Just to put up some resources for IETF 115 in London. Welcome back to London. And please especially keep an eye on the, if you need technical assistance, see the reporting issues page. That's also the meeting trouble desk? Yeah, okay, yeah. I used that this afternoon. Ground rules are that we are doing requests for conversation here. It's a good way to find people at the IETF to talk to for various reasons, and we don't actually gatekeep on what those reasons are. Presenters will tell you about that. Each person gets 4 minutes from go to please applaud. At 4 minutes, we will start applauding. We'll practice that on the next slide. When you hear applause, please hand the microphone over. We don't do questions here. Like I said, each person is providing follow-up info. In-person attendees can follow in-person presenters to the bar, of course. And just so you can follow along, we're using the data tracker for all slides. So we will let the conversations begin. And yes. Thank you. So this is the good job. So I will be running a timer, and at 4 minutes in, time yourselves carefully. At 4 minutes in, we will all start to clap whether the person has finished speaking or not. If they finish early, you get to applaud sooner.
Mark isn't here, so
I'm sorry?
Mark isn't here.
Right. Okay, so first speaker, Mark is not able to be with us here tonight. He has uploaded slides, and we just kind of pass through those real quickly here. I thought this looked really interesting, and yes, 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 yes. So as Phil is coming up, I am finding my speech timing app, which I only use at IETF meetings.
Okay,
You timing?
I'll start now. Yeah, I'm Phil.
Hi, Phil.
So next slide, please. So you might have seen this tweet go out in the Twitterverse that burning down the Twitterverse might be an accelerant to creating X, the Everything app. And that had me thinking. Because in the comments, next slide, please. One of the comments was, well, if you want to deliver an end-to-end secure everything app in 2023, you better have started 5 years ago. And I thought, yeah, who's been writing an everything app for 5 years now? Next slide. So the mesh was designed, I've been talking about this here for, we had that BOF in Singapore. I've been mentioning, yes, it's designed to do end-to-end secure messaging, key management, and so on. One thing that I never mentioned, next slide, is that the original use case that motivated all of this was end-to-end secure social media. I wanted to have something like Facebook or Twitter, except that I wanted all my content to be encrypted so that whoever was hosting that service couldn't read it. By end-to-end secure, I mean the administrator of the website cannot read the content. End-to-end, in my view, is from my eyeballs to whoever wrote. So it was always in the plan, and so I pulled out that, next slide, please. And so, yeah, I've got a draft out there, describes how to use the mesh to build a complete communications infrastructure. And actually, there isn't very much extra work to do social media on top of synchronous messaging. Asynchronous isn't that much of a big deal. Video, just use WebRTC. That's already done all the heavy lifting to do that part of the communication. Next slide. So what do I mean by an open social media? What I mean is I own my account. I control it, and I can take it from one service provider to another without switching costs, without losing all my followers, without losing all that context that I've invested. That belongs to me, not my publisher. And I want users to be able to choose curators who are choosing content for them, not have somebody with an algorithm designed to make me engage by filling my feed with fascism. I want a social media that isn't a single person's point of view, and especially not when that single person can't think of a more interesting place to go in VR than his office. I want a multiverse. So next slide. So I'm building this stuff. And of course, what people will be saying is, oh, well, isn't Mastodon doing something like that? Well, yes, it is, but they're not using cryptography. Not yet, at any rate. If I can take my stuff and add it to the Fediverse so it becomes the encrypted part of Fediverse, that's great to me. We've got all that encrypted stuff in the black network, and there's also the red network you can visit for the things that don't need to be private. Next slide. So the big question here is, what do we call it? And I think I've already got the name, everything. And, it might be the catalyst to building the everything app. So if you're interested in building a social media that is for the people and not for the billionaires, please come and talk to me. I've got a draft out there, everything, and that shows how you don't need a lot of mechanism to build something that is useful and matters.
Thank you. We have Roland next, and next up after Roland is Jeffrey.
Yeah, hi. My name is Roland, and I'd like to introduce Kira, which is a scalable ID-based routing architecture specially designed for control planes. And for control planes, connectivity is really important. So the first goal is to uphold the connectivity, while the second goal is to be also route efficient. And we want to provide a highly resilient control plane. Scalability was one objective, and here we targeted at hundreds of thousands of nodes, which could be present in a single domain. We route on node IDs, so there's no natively in that sense, so we have no ID to locator mapping, for example, and the scalability is achieved by having very small routing tables which scale logarithmically with the number of nodes. And every node ID has an associated path vector, which stores the route. The routes in the routing table actually are shortest path routes. And one specialty of the solution is that we have a selectable memory stretch trade-off per node. The whole solution is designed to be zero touch, so no configuration is required. So also no configuration mistake can take your control plane down. It also works well in various topologies out of the box, so no special versions for data center topologies, which are denser than other sparser topologies and so on, required, which we call topological versatility. It is loop-free even during convergence. It uses path IDs as labels in its forwarding tier and some kind of label switching. And so out of the box, it provides zero-conf IPv6 connectivity. Next slide, please. So what else did we do? We created also a special end system mode because end systems don't route, so they don't need routing updates and so on. So we can reduce overhead. It also supports multipath routing and forwarding. It has a built-in DHT, which is a key value store in a distributed manner. And so name or service lookups can be done with the help of the DHT or resource discovery. And recently, we also proposed a topology, very efficient and scalable topology discovery scheme based on that Kira solution. So Kira provides highly scalable, resilient zero control plane connectivity. And we think that is important for future networks because they are getting more complex. So if you want to know more, there's no draft out yet. We want to get feedback on whether people find this interesting to standardize. We think yes, but we want to hear your feedback. So there's a link to the paper, and I have two presentations scheduled at this IETF meeting, one in the routing area working group meeting on Thursday, and also in the ANIMA working group, which is related to the autonomous control planes. Thanks.
So we have Jeffrey come in, and next up after that is Rolf.
All right.
Wait for me to say go, and
We can skip this slide. Yeah. Next one.
Oh.
So mobile user plane is responsible for the data traffic between the user equipment or your iPhone and the data network. It includes,
Is it one back?
this is supposed to be animation, but I guess it, okay. Anyway, so you have those RAN elements, RU, DU, CU, and then you have, those are for the wireless part. And then you have the UPF, it's like a router or a broadband network gateway. And the UPF is connected to data network. With UPF being distributed nowadays for edge computing purposes, Now the UPF, and that also means the data networks are also being distributed, and that means they are implemented as a VPN. So you have the PEs there, and so the CUs are the GNOB centralized units. Now the CU, UPF, and PEs, they are all co-located at the same edge data center. Still, they are separate entities. So between the CU and UPF, you have the user traffic encapsulated in the GTPU tunnel, even if the UPF and CU are running on the same server. So the idea is what we combine those CU, UPF, and PE function into a single entity, which we call the NUP here. Now, you basically have a router with wireless interfaces and wired connection interfaces, and has the VPN PE functionality. Next slide, please. So this model of a router or switch with wireless and wired connections. Now the wireless technologies is only responsible for the wireless access, just like that IEEE technology for Ethernet connection to a router. And after that, everything else is IETF, IEEE wireline technologies. You do routing and switching, and all the features, VPN, eVPN, whatever, they're already in the wireline world can be applied to the wireless as well. No changes. Next slide. The advantage of this is that we no longer require this tunnel, so you get simplified signaling, optimized data plan, and because we now have a unified architecture, many special 5G features or procedures, they are no longer needed. You basically have a router and switch with wireless and wired connections. So this seems to be a natural evolution to people like us who are familiar with IETF wireline technologies, but it's a big paradigm shift on 3GPP side. And the work would have to be done in 3GPP, not in IETF. But what we have been trying to do here in IETF is to talk to people, especially the mobile operators, to talk to their architects to get their support first.
Jeffrey, you're getting real close.
Okay. If we get that support, then we can bring this to 3GPP for further discussion. That's it.
Thank you.
Spencer, can you hear me? Spencer, can you hear me?
You're remote, is that right?
That is correct. Can you hear me?
Yes.
Yes, very well.
All right.
What?
Who's
Now,
Spencer?
let's go.
All right. My name is Rolf, and I've been doing this work together with Valentin. He did most of the heavy lifting. And together we want to supercharge traceroute. And I'm going to take the next 3.5 minutes to explain to you what we mean by that. So today, when you want to assess the state of the network or when something goes wrong and you want to figure out what is going wrong, then the IETF has defined quite an extensive set of OEM mechanisms that help you with this. So for example, we have Young, netconf, and restconf, and that lets you, well, of course, configure your boxes, but it also lets you monitor everything related to your boxes. But it's boxes that are under your control, obviously. And in addition, and more recently, we have things like in situ OEM or IOAM, and there you add data or information to your data packets, and that lets you measure everything that is related to your segment of a path. So that segment of a path that is under your control. And we have a bunch of other things like IPFix to export flow level information from a router. We have a bunch of mechanisms that have been defined by the IETF, but they all have in common that you have to be in control of those boxes. You have to be operating those boxes. And the question is, what about the public internet? So the places on the internet that you are not in control of. And there you basically have two tools available. One is ping, and ping gives you very little information. So you have interface reachability. You know that interface is reachable, and it gives you a round trip time estimation with it, but that's all the information ping gives you. And then on the other hand, you have traceroute, and traceroute is more expressive. It gives you router level information. So it basically lists or enumerates all the routers from you towards the destination on the public internet, and it gives you round trip time estimations for every hop and the final destination. And what we would like to do is we would like to make traceroute better in the sense that we also want to estimate the reverse path, because today's internet is highly asymmetric. That means the forward path and the return path are typically not the same, and we would like to basically illuminate this reverse path using a better traceroute. Next slide. So we have published an internet draft in int area, and in the orange box you see the link towards that draft, and we would like you to actually read the document and then join the discussion in int area. We also have implemented, we like running code, obviously, so we have implemented reverse traceroute, and we would like you, if you could, host a reverse traceroute endpoint. It's a eBPF, a small eBPF program that you can run on any Linux box, and it would offer reverse traceroute to clients. So if you don't want to do that, you could also help by running the client and send us the output, because we would like to assess how good this implementation is, what the properties of the implementation are, what we see on the public internet. So running the tool would be very helpful to us. And remember, the internet is for the end user. That's at least what RFC 8890 says. And so is this work. So this is for people and organizations that don't necessarily run the infrastructure, but they have something that is running in the cloud, and they would like to measure path quality from their point of the network to another point over the public internet, or for organizations that consume services of the public internet. So for everybody that is not running the internet or running parts of the internet. So there's a website you can look at. There's clearly the draft you can look at. The GitHub, if you go there, it's empty at this point in time. We're still fixing a couple of things and cleaning up the code. But in a couple of days, we are hopeful that it's going to be there. But if you would like to help us run reverse traceroute, please send me an email. Thank you.
I'm looking for Andrew Kamling. Andrew Kampling, are you with us? Ah, yes, excellent. About ready? Yep. Let's do it.
Hi, good evening, everyone. I'm here today to talk to you about the encrypted client hello and specifically deployment considerations associated with encrypted client hello, or ECH. There's a number of us that have been working on a draft covering this topic. Arno Tadai from Broadcom should be around later on this evening. His flight hasn't landed yet. So anyone's interested, either speak to me or speak to Arno through this week. Next slide, please. A very brief bit of context. ECH is a mechanism in the TLS protocol that's been added to encrypt the client hello message, which has previously been in plain text. It builds on the previous encrypted SNI proposal. It is like a superset of that within the TLS working group. And if you're interested to see more detail about ECH, I've put a link to the relevant draft, which when I last checked was at draft 15, but is being continuously updated. Next slide, please. The reason we're interested in this topic is by encrypting that sort of plain text data, that does have implications for end users. And we're keen to make sure that's understood. So RFC 115-HOTRFC-20221106-1800 sort of recognizes that making networks unmanageable is not an acceptable outcome. RFC 8404 looks at sort of security and network operations and practices that could be impacted by the move to end-to-end encryption. And it's, I think, perhaps not widely understood that the SNI data is widely used by on-path security actors. So it does have quite significant implications for a number of different groups of users, particularly sort of enterprise and consumer. Next slide, please. RC 8744, which looked at the need for encrypting SNI, in our view, didn't really consider in sufficient depth the implications. I won't go through the detail on the slide in the interest of time. What we're aiming to do as a group is to fix that and actually write a draft which covers in sufficient detail what the implications are for end users and what actions they may need to take. Next slide, please. So with that in mind, if that's of interest to you for any reason, we'll be uploading a draft hopefully as soon as tomorrow when Data Tracker reopens, which will have the latest sort of thinking. It's by no means complete yet. We're certainly looking for people to add to the text. So if this subject's of interest to you, please look at the draft. And more importantly, we have a side meeting tomorrow evening at 7 p.m. local time in Richmond 6. So again, if this is of interest to you, please come along to that. If you're attending the session remotely, you can join us via Zoom. The links are on the screen and also in the side meeting agenda. So please come along and contribute to the discussion. And that's it. Thank you.
So we've got Daniel Petriap and John Border after him. And I'm actually running a timer here that you can look with the when it changes color.
All right, sounds good. By the way, I'm Thomas. I'm not nearly as nice as Dan, so I'll be clear about that. But we're here to tell you about vCons. Next slide, please. So in my day job, I'm the CTO of a company that talks to a lot of people, about 1 million every year. And I'm charged with taking care of their data as if it were my company's data, but I can't. And so I'm here today to talk about vCons. And I want to talk about why this is important, because this is the intersection between two really important things: customer data privacy and machine learning and artificial intelligence. And it's my job as a CTO of my little company to make sure that we honor our customers and return to our shareholders. A vCon is a construction that allows me to understand what's exactly inside a conversation so I can use it appropriately. I can share it appropriately. I know what I shared. And when a customer asks me, could you please delete my data? I can, because I know what data I have. Next, please. So the vCon has 4 parts to it. The first part is obvious. It's the conversation. It's the video. It's the audio. It's the chat transcript. Maybe it's a lot of those as a person's gone through a channel. That's the obvious part. The second part, though, is the parties who actually had the conversation, identified as much as you possibly can. We're living in a world where 2 things are important: anonymity and identity. Sometimes it's really important to know who said it, and sometimes it's important not to know who said it. The 2 last parts of a vCon are the analysis. What does it mean? What are the semantics around it? What are the things that let me know that, oh, this is full of profanity, or this is about a Ford Camaro, or the customer was angry, or my agent was rude? That's part of the conversation, as is the context, the attachments, the last part. What are we talking about? In my company, it would be the lead. In your company, it might be the PowerPoint presentation. Next. So this really solves a lot of practical problems, but the most important one is the responsibility problem. That I'm being asked to have responsibility for data, and I don't know what it is. And more than that, if we standardize the format of what a conversation looks like, then we can ask questions like, well, why didn't you authenticate that? We can ask questions, we can interrogate it, because there's facts to be interrogated. And then I think this is the IETF's job. This VCon idea came out of a different group. We represent, a couple dozen people who think this is a great idea in the programmable communication space. But the issue is that we live in a very siloed world. My little company has 5 communication systems. 5. And, I understand that there are very large vendors who want to do it all for you, but I can't think of a single one who is doing it all for a single company, because the biggest voice company doesn't do chat, doesn't do video chat. So my data engineering of conversations is really limited because I don't have a standard by which I can interchange data, validate it, anything. Next, please. So for more information, we have a mailing list. We just put in a draft. But maybe a great place to start is the white paper that was written by a half a dozen people from the communications industry to tell you how important this problem is to solve. This is an open source project. This is an open source idea. We are not looking we're looking to solve this for every person. And I think you as people should be interested in this. And so we're here right now. We have a dispatch meeting tomorrow at 9:30. If you're interested in privacy, if you're interested in machine learning, please be there and please support us. And then, listen, if you're around on Thursday night, I'm going to need a drink, and I'm going to need someone to have a drink with me, and we're having a birds of a feather session at the very same time. So if I were you, I'd come aboard. Thank you very much.
Let's see. So we got John, and then we've got Ken McMillan after John. And resetting and starting.
Okay. I'm here to advertise a side meeting for the Encrypted Transport Over Satellite group. It's a non-working group mailing list. Next, please. Basically, we started it to talk about the transport protocol being encrypted. In particular, it came out with QUIC because on geosatellites, it's traditional to use performance-enhancing proxies, which operate at the transport layer. You can't do that with QUIC. That's where we started the discussion. We've actually expanded since then to talk about LEO topics with related to routing and all kinds of stuff. So that it's basically now more of a sort of a general satellite list. The mailing list is up there and you can subscribe at that link. Next page. So this is the agenda for we have a set of presentations at the side meeting. Some topics about high BDP networks. I think mostly focused on TCP, but I'm not sure. Then we have a quick and FEC presentation. Then the reducing acknowledgements, an IETF quick presentation. And then we just added a BBR for quick over geo presentations. So the focus, as you can see, on this particular EDOSAT meeting is geo. So the meeting's Wednesday at 11:45 in Richmond 6. We'd like to see you there, but we also have remote participation set up. And again, if you need more information, you can email me or email the EDOSAT list. That's it.
Excellent. So we've got Ken.
Okay, thank you. And I'm going to be talking about some stuff that's joint work with Lynn Ortzuk. So what I'd like to do in this short talk is make a case that formal specifications can provide benefits in the IETF process. Next slide, please. So by a formal specification, what I mean is just some unambiguous mathematical description of a system, usually described at some interface. And that can be either represented in logic, or it might be represented in some more familiar form, like an abstract programming language. So there's an obvious benefit to writing specifications in that way, which is that we have then unambiguous documentation that can be used by both implementers, and users who are building on top of a given interface. So that specification acts as an interface contract. But a less obvious benefit is that we can do much more rigorous testing when we have formal specifications. Not only can we do runtime monitoring to make sure that we're conforming to the spec, but we can, for example, automatically generate more rigorous unit tests for the different roles in our protocol in a way that can expose errors that we don't see otherwise. And of course, finally, we can do formal proof with a formal specification. And that is a use, and it's often very useful to think of high-level properties that we want to prove, but we can get a lot out of formal specifications without doing verification all the way down to the implementation. Next slide, please. So as an example, we worked on a formal specification of the Quick transport protocol, where we were using a language called Ivy that looks like an abstract programming language to do a wire specification of Quick. And this was at a level of detail that was sufficient that the specification itself could interact directly with the clients and servers. And we used it to automatically generate tests for compliance for a bunch of servers and clients that were being developed. And what we found was we exposed a lot of errors that didn't come out in interoperability testing. A lot of those were compliance errors where we either misinterpreted the spec, or the implementer did, or there was an ambiguity in the spec, and a lot were even low-level code crashes that just weren't exposed by testing. So a lot of those errors in turn were potentially exploitable. For example, we found a case where you could exploit the flow control mechanism in Quick in order to read arbitrary memory out of the server, or a case where you could have a denial of service that exploited the client migration feature of Quick. Next slide, please. So one of the takeaways from this then is that interoperability testing isn't really enough because it doesn't tell us whether the implementations are really compliant to the RFC. And that can give us a lot of issues, especially security issues, when we get non-compliant implementations out in the wild. This happened, for example, with downgrade attacks in SSL. Formal specification could be part of that solution because it allows us to find out before things get in the wild whether they're really compliant. So there's a lot of research left to do here. There are hard trade-offs between readability of the specs, testing issues, formal proof, and so on. But what we're mainly interested here is try to understand how formal specifications can be usefully and practically integrated into the IETF process. And if you're interested in this topic, there's a meeting coming up on Thursday of the Usable Formal Methods Research Group, or please contact us directly, and we'd love to hear from you. Thank you.
So the next person that's on our list is Rich Kulawek, and I am not seeing him in MeetEcho. He was expected to be remote. He's lost power at his house twice in 2 days. He let us know that he was trying to join using a neighbor's bandwidth, but he said web pages were painful, so he didn't think he could get in on MeetEcho. And if he's not here, it's not for lack of trying. His slides are uploaded to the data tracker and available here. So if this looks like an interesting topic to you, please follow up with Rich. That brings us to Sam Hurst. And next up is Ignacio.
Hi, I'm Sam Hurst. I'm a project R&D engineer with BBC Research and Development, looking mainly at media streaming. And I'd like to talk to you today about my little project, which is trying to run SIT over quick transport. So next slide, please. So it is just a mapping of session initiation protocol over quick transport, very much inspired by HTTP3's mapping, given that SIP is quite close to HTTP 1.1. The original idea came from some work I did on trying to run RTP over quick, but one of the problems I was having was, okay, well, I can send media, but how do I negotiate that in a nice way? And specifically when the use case I was looking at, which is there is a reporter in a field trying to get some media back so we can put it on the news. Maybe they are on a connection they don't particularly trust. We want just one single encrypted tunnel. So Quick looked quite nice for that. The idea of sending live media over Quick is a very active topic. So there's obviously the new media over quick working group. There's stuff in AVT core as well, talking about this. So yes, we've been looking at the possibility of reusing SIP semantics to do control metadata for that. Next slide, please. So like I say, it's inspired by HTTP3. So I've got data frames in there for carrying the SIP requests. Headers are using QPAC compression, specifically just so that we can reuse a lot of the existing HTTP3 stack, so it should be hopefully easier to implement. So like I said before, the intention is to allow for media sessions to use the same quick transport connection to do the media and all of the control. And specifically, the design that I've come up with decouples the quick client and the quick server from the user agent client and the user agent server in SIP. But I've also kept unidirectional stream types and datagrams available for the media transport. Next slide, please. So the internet draft is now actually up on Data Tracker. I managed to do that on Avanti Train Wi-Fi amazingly on the way down this morning. So please do go and have a look at that if you're interested. Happy to accept any and all feedback, but I'm also specifically looking for what avenue is the best place to continue this work. Is this something for SIP core? Is this something for AVT core? Or is this something that should be living in mock? So that's everything from me. Thank you very much for listening.
So we should have Ignacio and oh. Yes, remain calm.
Hello, I'm Ignacio Castro from the University Queen Mary of London, and I have a question for you, which is how is the IETF doing? And that's what I've been trying to analyze with some colleagues. Next slide, please. And we have been crunching and looking into the emails, the drafts, the RFCs, how long it takes, and many other details. And what we find is that the conversation seems to be increasingly complex. It seems to be increasingly harder to publish, and it seems like there is an influential minority that is growing increasingly relevant inside of the IETF. Next slide, please. And if this sounds interesting, we have been working together with colleagues from the University of Glasgow, and we have already published some papers which have much more details. And this is part of a broader project called SodaStream. Next slide, please. And as a part of this, we're also trying to create tools that might help the community. In particular, right now, we are developing a tool for supporting cross-area review. If you scan that QR code, that will bring you to the website, and the tool is there. And we are trying to find good matches between drafts and reviewers. And we do this by using a combination of NLP tools and social network analysis. If this sounds interesting, please help us. We need a little bit of information to ground truth the findings that we have. We are also preparing a few other things to gather more information, like a survey on, like the survey that I'm saying. And if this in general sounds interesting and sounds like something that you think that more people should be doing, we have a side meeting with the idea of preparing a research group called RASP, Research on Internet Standards Processes. And that will happen on Thursday, and everybody's welcome to join. Thank you very much.
And next speaker is Hans Dieter. And I wanted to congratulate Ignacio, because this is the first HOTRFC talk I've seen where you actually tried to put people to work while you were talking. So,
thank you. My name is Hans-Dieter Hiep. I work at the CWI in Leiden in the Netherlands. In the past couple of years, I've completed a research project supported by the Next Generation Internet Initiative. Next slide, please. During this research project, we were basically studying synchronization over the internet, how you can synchronize components. And we made a kind of a discovery, or at least we found an idea that we thought was very interesting to share. So that's what I want to do right here. You know probably Shannon's information theory, right? This basic idea of what information theory is. You could code and decode, and then you can use basically bits to encode any kind of message that you want. But the problem with this notion is that this is a time insensitive notion. Whenever you encode it, this is done statically. You don't regard the moment when you encode it or the moment that you decode it. And so it seems that this capacity of a channel measured in bits per second is sufficient. Next slide, please. But it turns out that you can introduce a so-called side channel, and also Shannon was aware of this idea, but this is less widely known. What the idea of a side channel in this case, time, is that if you have two processes that are synchronized in time, so that they have a clock running at the same speed, then you can send a signal, just a single signal, and the moment of reception is then significant. And whenever you synchronize these machines, then you can send just with a single signal more information than is present within the signal. So then we have basically a theorem, which is that the effective capacity is higher than the capacity. And now an important new measure that you have to also consider is that of jitter, which is unpredictable variation in the delay whenever you communicate. Next slide, please. So based on this insight, we basically want to develop a new internet protocol called TMP, standing for Time Modulation Protocol. We are really in the research stage right now, and it would be really nice to get into contact with more people. So, for instance, to collaborate on prototypes, but also for working on better models for predicting delays. Let me end with what are the potential benefits of using this protocol. There is a potential increase of effective capacity, which might be interesting whenever you want to send more data than whatever is metered on links. And very important for end users application is that you could increase confidentiality by hiding data in time. Thank you very much.
So I've got Dan Sexton coming up next, and then Travis, you will be our last requester for conversation.
Hi, Spencer. Can you hear me okay? Sounds
Hear
like
you
it. Great.
very well.
Thank you. So hello, everyone. This is my first time attending IETF, and I come with a question and a challenge, which is privacy preserving web filtering possible? If I can have the next slide, please. So I work at the IWF. We're a charity in the UK, and we work to find and remove child sexual abuse material from the internet. A really crucial part of that work has been providing data to industry to enable detection, blocking, filtering of known content by platforms, ISPs, and filterers. As internet standards have developed and encryption has become more commonplace, those methods have become less effective. It's been harder to detect, it's been hard to block. So the challenge really is, can legitimate legal web filtering coexist with secure and private internet? Can advances in encryption and privacy enhancing technologies be used to filter harmful web content without compromising user privacy? So the next slide, please. So what I'm here to do is to try to engage with the community, to talk about the issue, to find out about any existing work that might already be going on in this space, or similar technologies, privacy enhancing technologies that were used in other areas that might be made to work with web filtering. I have a public side meeting on Tuesday at 3:30 in Richmond 6, and I would encourage anyone that is interested in the topic or might be able to post some challenges or potential solutions that might develop into maybe a future proposal or a standard implementation. So very, very welcome if people are able to make it to the public side meeting or to contact me otherwise. Thank you very much, Spencer. That's everything I had to say today.
And we invite Travis to the stand.
All right, I'm Travis. I'm here on behalf of the Spec Core team for Matrix. Not a lot of time, but a lot of information, so I am going to speed run this. Please try and find me afterwards, or just message us on the Mimi mailing list. If I can get the next slide, please. So there are three major questions that I would like to sort of cover. First, what is Mimi? Why are we doing this? How does it affect us as Matrix? And sort of where are we at currently? If I can get the next slide. So yeah, what is Mimi? Next slide, please. Mimi is the More Instant Message Interoperability Working Group currently here at the IETF. They're having a BOF on Wednesday to actually form themselves into a proper working group. And it's created out of an interest for the EU's Digital Markets Act, or DMA. So in that DMA, gatekeepers or large messengers are required to interop with each other, as well as other sort of messengers in the space. As Matrix, we think this is a good thing because Matrix is an interoperable open standard for secure decentralized communication. And you might see where this is going. If I can get the next slide, please. So currently, gatekeepers kind of look like this today, where you have, say WhatsApp and Instagram, they're able to communicate with each other, and then Twitter's kind of off to its side, and there are others, of course. So with the next slide, the DMA kind of wants something like this, where you just apply magic in the middle, and then they're able to talk to each other. Next slide, please. The trick, though, is that with encryption maintained the entire way through. So because WhatsApp supports encryption, all three would need to support encryption and anybody else sort of in that conversation. So next slide, please. So how would we do that? Next slide. With Matrix. Next slide. So with Matrix used for interoperability, you convert everything to a home server, at least on this sort of public internet front. So they're able to communicate with each other. And briefly, next slide. These are the sorts of bits that we'll need. So it's just the Federation API from Matrix, extensible events, that's just the format that we send over the wire, and then a governance process to actually make sure that Matrix can be properly incorporated. We're gonna skip the next 3 slides. These are just the bits. The slides are up on there. Next slide, please. So where are we currently at? Next slide. This is the rough timeline. So Matrix was created back in 2014. We're currently in November 22, where Mimi becomes a working group, and we have a lot of conversations ahead of us, and we're hoping that Matrix will be sort of adopted eventually, and that's kind of our goal here. Next slide, please. So how can you help? Next slide. Just let us know. What do you think? How can we actually make this kind of work in a governance process? That sort of stuff. If you're on Matrix, that's the room to sort of talk to. If not, otherwise, just come talk to me after or, on the mailing list. But that's all. Just next slide, please.
So this brings us to the end, right? Yes, this brings us to the end of our time together at IETF 115. I'd ask for you to think about maybe 3 things as you're on your way to the bar this week. First, let people know what you thought about this format and whether it seemed helpful to you or not. We got one request to present about 40 minutes before the social started, and we were able to do that thanks to a lot of assistance from the Secretariat. So please tell people what you appreciate about them also. Anybody can talk at HOTRFC. If you think that it would be interesting for you to talk about ideas you have and that this seems to be a helpful place, be thinking about that. We're actually on the agenda on an ongoing basis now. So you can be thinking about what to send in and expect that there'll be a call for proposals. And the third thing is, if this seems helpful to you and you'd like to help, please let me know. Please let us, me or the HOTRFC team at HOTRFC at IETF.org, and we'll see what we can work out. Thank you all for coming, and enjoy the rest of your IETF week, and please do the right thing.